Okay, good afternoon, everyone. So this recording is just to help me um, revise what I've learned in lecture 3. Lecture 3 is about money and bonds. So we combine the money and the bonds into the lifetime budget constraint and then derive the optimality condition. And finally, we can see the economic intuition behind that. So there are 3 rows of money. So start with the basics. One is the unit of account, and there are there are 2 others as well, which I will not talk about. Now we're going to incorporate money into the utility function, because money in 2101 in earlier economic modules does not give person utility. The person receives utility only from the goods or services he consumes, not from the money itself. But now we see that some people still like the money. They like to hold money on hand. So maybe the money alone gives them utility. So we are going to incorporate that. And we are using the notation here, U, CT, and T over PT. And the reason why we divide MT by PT is that we are going to use the real money demand, not the nominal money. The nominal money covers the price inflation, a lot of things. What we really want is the pure purchasing power we have, what utility it can derive from us. So this, we call it money in the utility function. MIU, as my prof said, of course I'm not you. So remember the joke. It's a very interesting code joke. So let's then incorporate bond into this. So we are simplifying the condition, 1 period, 0 coupon government bond. So conventional monetary policy operates through the short-term bonds, right? 30, 60, 90 days. And we're using, I think we are using that because that's the primary tools the government use to do open market operations. So first we have the price of the bond. You can think of a price, because the future value we define to be $1. So the price of a bond now would be, for example, you can say 90 cents, 80 cents, around something around like that, below 1, because you can't expect you pay more. For example, we pay $1.5 for $1 in the future, right? That doesn't, it contradicts to the time value of money. And the interpretation of this I here, because we derive a lot of things, the I is the interest payoff of a bond. But we can see an alternative interpretation of it. So that's the opportunity cost of holding money. So what can you do with holding money? The second best thing you would do is to buy a bond. So buy a bond gives you return. Holding money doesn't give you a return. Yeah. So there's an inverse relationship between IT and price of the bond at time t. That is because as the interest rate go up, people tend to buy more of the bond, and sorry, let's think of another way. So as the price of the bond go up, the return you get from the bond is actually less. So I think it's the better way to start is to start with the price of the bond. Change in price of bond lead to a change in the interest payoff of the bond. Okay, so this is our market operations, open market operations. Usually the Federal Reserve will announce their interest rate cut, and then they will conduct open market operations, whether they buy bonds or sell bonds, and then they are able to, lower or increase the interest rate to their desired level. Okay, so for example, let's take a moment to see what happens if the bond market reduces. So that means the central bank is buying the bonds back. That means they are um, um, injecting the money into the economy. Okay, so so this is a bond market. They reduce the bond, so the bond economy will reduce, right? In the meantime, the supply of money would increase because of the government use money, central bank, use money to buy the bonds. So yes, so bond reduces, money increases. So inverse relationship, right? Then let's look at the real money demand and how to construct this budget constraint. So we can see the budget constraint from two perspectives. One is the expenditure and resources perspective. So here you see all your expenditures at time t. On the right hand side, you see all the resources you have in time t. What this means is that, for example, in time t, you consume the real consumption plus times price. Then your new bond you want to buy, right? Then the money you want to have, then the stock you want to buy. On the right hand side, you receive your income, which is income, right? Then you receive income from dividend. You receive the stock price today times the amount of stock you bought last year. Then you have your previous money, what you save previously, the money, and your old bond matures. That will give you face value $1 times the amount of bond you bought. Okay, the second perspective is to look at it from a flow perspective. So what goes in and equals what goes out, right? So in that case, only in that way your budget can balance, right? So what goes in? So I think the first left-hand side is what goes out. Goes out, consumption, expenditure goes out, and the you buy money, you buy bond, then goes out. You want to hold more money, then it goes out. Then you want to buy more stock, goes out. What goes in? So the money, the income, the new bond that the old bond matures. That money you have now, and dividend you can. That's an inflow, right? So first of all, let's construct a Lagrangian function. Start time t. So the typical setting is like this. You use the utility function 1 period times beta times the second period utility and times beta square, because we need to introduce this impatience factor. As the time goes by, your impatience grow bigger and bigger. Actually, the lower the beta, the higher your impatience is. How do I see it? For example, the beta is like a number between 0 and 1. So if you've got a number, let's say 0.001, then this value will be discounted to a very, very small value in today's money. So that's the reason why as your beta is lower and lower, then your impatience grow higher and higher. So you also need to plus the the budget constraint. Move everything to one side times the lambda, and doing the same thing and still using the lambda. that lambda is mainly for operational efficiency to do calculations faster. Next, we're going to compute first order conditions with respect to C1, AT, BT, and 9T. Why do we with respect to that? So the key thing here is those are all choice factors, choice variables. What this means is that these are the things you can control. What you cannot control, for example, you cannot control the dividends the company is going to pay you. You cannot control the stock price. You don't know the stock price. Yes, so we only derive with respect to the things we can control. So after that, we'll see two functions, which is pretty long. And if you simplify those, long conditions, and then you gradually see a pattern here, you summarize here, and actually from the second equation, you can basically see the stock price equation we discussed before. For the third equation here, you can see this is the price of the bond, right? And yes. Next, let's look at the simplification from combining 1 and 4th equation. Okay, so from 1 and the 4th equation, we get u2 blah 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 over u1 blah 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 is equal to it over 1 plus it. So this it over 1 plus it is definitely not cannot be easily seen in the equation. But from the point here, you can basically see that there is lambda t times pt. There is something else. There is lambda, wait a second. There is, look at here, 1 over pt minus lambda plus beta over beta times lambda t plus 1. And if you could, see that, and then simplify from there, there are many things, and doing something, you'll get this finally. So because I don't want to speak too much about the the nitty-gritty things, so I will skip that part. And here on the right hand side, there is a method for you to derive respect to MT, because here you have MT over PT, but you only want to derive it with respect to MT. So here is how to do it. You use a trick to, like bottom here and the upper here cancel off. So you get that answer. And you see that, for example, if you got this utility function as ln t times plus ln real money demand, and you doing the U2 U1 there is actually the marginal utility. Yes, so the 2 means the second item. You derive respect to the second item. That's like MU, like MUY, right? And this is like MUX, right? I think it's right. But then you derive this, and then you see, oh, the real money demand is actually very simple. So what is the short run effect of this money demand? It's a fairly simple process, right? So the Keynesian view is that the money is not neutral. Because of the price rigidity, price will not change easily, because maybe there is a new union in a company that prohibits the company to lower the price of wage, right? And generally, the price takes longer time to respond, right? Because of the the information is not conveyed immediately to the individual consumers and individual buyers, individual producers, right? So if MT goes, which one? So if MT goes up, the money shop, right? Then the CT must go up. And here, RBC, real business cycle view, they think that the money is neutral because the price is not rigid. So the consumption will not change because as long as the price, the money, the nominal money changes, right? Because the central bank only controls nominal money. They don't know, or they know, but they don't have the money called real money on hand. Don't have the note says this is real money. No. So as long as the nominal money goes up, the price will follow. So in the end, there is no difference, right? So CT reflect the optimal choice. Yes. There is no reason for CT to change because it is the optimal price ultimately. So you will see that normally you will have aggregate supply curve at PT if you believe in Keynesian view, because the price is rigid, will not change. So yes, so here I have extreme one, that is the expansionary monetary policy will shift AD and intersect this AS curve here. And as you can see, the consumption goes up, the GDP goes up, right? The second thing is the RBC view. The RBC view says price change quickly. So whenever the money changes, right, the monetary policy, expansionary monetary policy, AD shifts, the price will move up. How do you see this? Well, you draw a line here. As soon as the AD shifts, then the price will follow. So you will have, how do I draw a line here? Yeah, I see a line here. Sorry. Price will become like this. So as long as the thing goes up here, right, then price will go up here. So that's also another extreme. So the price will be like the price will go up. So that is the intuition we have for the short run effect. But in the long run, the steady rate, in the steady rate, real variables will not change. That means CT is equal to CT minus 1, right? And IT is equal to IT minus 1. So anything that is real will not change. Anything that is not real, for example, price, it will change. So finally, we see we use T minus 1 period and T period, both period equations to analyze. And in the end, you will see canceling all the factors, impose the steady rate here. 1 plus mu over 1 plus pi is 1, which means mu is equal to pi. Now, the good question is, what is mu? Mu is defined as the money growth rate. Pi is defined as the inflation rate. Yes? So in the end, you will have this. The money growth rate must be equal to the inflation rate. So that's the end of this revision. Hope you like it. Bye.